Hello, algebra students. I hope you're doing well. We are continuing in systems of equations because this is all in chapter 6. But now that we know the 3 strategies to solve a system of equations, we're going to talk about applications of this. In other words, real world problems or word problems. So what I'd like for you to be able to do by the end of this lesson is to solve word problems that involve systems of equations, and you're going to solve it by using the best method possible. So let's just review what our 3 methods are. We have graphing, substitution, and elimination. With graphing, this would be a good method if you need to visually kind of see what's going on. It's an image of your 2 graphs. With substitution, this is going to be easier when one of your variables is already isolated, or if maybe your equations are quite simple and it's easy to isolate a variable. And then with elimination, we are going to use that if your x's and your y's are already lined up to where you can easily get them to where they would be eliminated. So you just have to look at each problem individually and consider your options and then decide which way should you go about doing this. So in example 1, it says the local zoo is filling 2 water tanks for the elephant exhibit. One tank contains 20 gallons of water and is filled at a constant rate of 10 gallons per minute. The second water tank contains 48 gallons of water and is filled at a constant rate of 3 gallons per minute. When will the 2 tanks have the same amount of water? So what we want to do is, I'm just going to highlight this part that is describing what the actual question is. We're trying to figure out, when will the 2 tanks have the same amount of water? After how many minutes? So that's the final answer that we're trying to get to. And I think that when we know what our goal is, it's easier to take steps to get there. So our first step is going to be defining the variables. What are the things that are fluctuating in this? If you're thinking tank 1 and tank 2, no. And if you're thinking 10 gallons per minute, or 3 gallons per minute, that is a rate of change. So a rate of change is not going to be our variable. Our variables are actually how much water there is and how much time has passed. So I'm going to say x is equal to time, because x is independent and 99% of the time is also independent. And I'm going to say y is going to be amount of water. Defining your variables is very helpful for your first step because it helps you make sense of what's going on in the problem. Step 2 is to write your system of equations. So we're going to need to reread this to see what's going on. So we have one tank contains 20 gallons of water and is filled at a constant rate of 10 gallons per minute. So let's write an equation for that sentence. It begins at 20, and then it's getting more full, so that's going to be plus. And if it's 3 gallons per minute, then it's going to be 3x, or sorry, 10x. My apologies, I'm looking at the wrong sentence. It's going to be 10x is equal to however much water it produces. So that's going to be y. So it's beginning at 20, and it's gaining 10 gallons per minute. That's the x, and that's going to get us however much water there is after a certain amount of time. Let's do the second sentence now. It says the second water tank contains 48 gallons, so we're beginning at 48, and it's increasing by a constant rate of 3 gallons per minute. So now it's 3 per x equals y. So now that I have my 2 equations written out, it's up to me to decide what is going to be the best way to solve this. Do I want to use substitution or elimination? Well, based off of the fact that both of these are already solved for y, I'm personally going to use substitution. But remember, this is what is best for you. You're allowed to solve it the way that makes most sense for you. So if you prefer elimination, then you're allowed to do that. Because both of these are y, I'm going to take this expression and set it equal to that y right there. So now my new equation is 48 plus 3x equals 20 plus 10x. Now I'm going to start solving. So I'm going to subtract 20 from both sides. And that gets me 28 plus 3x is equal to 10x. Now I subtract 3x from both sides. And I'm at 28 is equal to 7x. Divide by 7, and remember, a clue is usually division is your last step. So I have x is equal to 4. Now remind yourself what x represents. X represents the amount of time that has passed. And our question is, when will the two tanks have the same amount of water? Well, they will have the same amount of water after 4 minutes. This is because at 4 minutes, both of these equations are equal to each other. So I'm going to say at 4 minutes. And that's your answer right there. Usually you do solve for x and y, but because this question specifically asked only for the amount of time, I'm not going to keep going because I want to answer the question and then move on. That's just a strategy for test taking, like when it's timed and things like that. Okay, so let's do another example that's very similar to that. It says the same zoo has 2 other water tanks that are filling up. One tank contains 10 gallons of water and is filled at a constant rate of 2 gallons per minute. The second tank contains 6 gallons of water and is filled at a constant rate of 4 gallons per minute. When will the tanks have the same amount of water? So we want to identify our variables again, and they're going to be the same as the last problem because this is modeled after the same thing. So x is going to equal time, y is equal to water, and we need an equation for the first tank and an equation for the second tank. So one tank, it begins at 10, and it is filled at a constant rate of 2 per minute. So that's going to be 10 plus 2x is equal to y. And then the second tank begins with 6, and it's filled with at a constant rate of 4 gallons per minute. So 4x equals y. Now, these are both lined up, but notice that both of the equations are already solved for y, so I'm going to use substitution again by setting these equal to each other. So I'm going to say 10 plus 2x is equal to 6 plus 4x. First, I'm going to subtract 6 from both sides, getting me 4 plus 2x is equal to 4x. And then I want to get the x's together. So I'm going to subtract 2x from both sides. To get something to the opposite side of the equation, I have to do the opposite operation. For this final step, I'm going to divide by 2 and get 2 is equal to x. In other words, these two tanks are going to be filled to the same amount after, or at 2 minutes, I should say. Now, if it also asked how much water will they have at that point, then we can figure that out as well. We could take this x equals 2 and substitute it into one of our equations. So if I had 10 plus 2 times 2 is equal to y, then that would be 10 plus 4 equals y, or 14 equals y. That would then mean at 2 minutes, there are 14 gallons of water in each tank. Now, the question didn't ask for this information, but I still wanted you to see what that information would actually be telling you if you solved for y as well. All right, let's keep going and do another word problem of a different style. In example 2, it says your school is putting on a play. They are selling child tickets for $8 each and adult tickets for $10 each. There are 400 seats total in the theater. If a performance sold out and the box office made $3,800, how many children and how many adults attended the performance? That last sentence is telling us what we need to figure out. Because it's in the question, it's letting us know what the variables are. We are trying to figure out how many children and how many adults. Those are the variables. And remember, one of the first steps you're going to want to do is identify the variables. So I'm going to say X is equal to child, Y is equal to adult. These can be interchanged. This is just how I'm doing it, okay? And now let's reread and see if we can find some equations in this word problem. So your school's putting on a play. They're selling child tickets for $8 and adult tickets for $10. So I now know that that's going to be 8 by X and 10 by Y. So I'm going to go ahead and say that 8X plus 10Y because we're making a profit from these. So if it's $8 per child, $10 per adult, and I get, or the box office earned a total of $3,800, I can now set the ticket price in sales equal to what the profit was, $3,800. It then goes on to say there are 400 seats total in the theater and the performance sold out. So there's 400 seats and it's sold out. That's letting us know 400 people total attended. So some amount of children and some amount of adults attended this play and it totaled to 400. So I'm going to say some amount of children, which is X, plus some amount of adults, which is Y, is equal to 400. Alrighty. Now that I have my two equations, I need to decide how do I want to solve this. I personally think that both substitution or elimination would work for this because just the way that it's kind of written out. But I do think that elimination would work just a little bit easier, for me at least. So what I'm going to do is I'm going to decide to cancel out the x's. Because I want to cancel out the x's, I'm going to multiply the bottom equation by -8. So now let's rewrite our two problems over here to the side. My top equation is still the same. I have 8x plus 10y is equal to 3,800. And my bottom equation is now -8x minus 8y is equal to, and the -8 times 400 is -3,200. Now I'm going to add these up and down. My x's cancel and I get 0. 10y and -8y is 2y. And 3,800 and -3,200 get me 600. So I can ignore this plus 0 because it's not changing the value of anything. And in order to isolate this y the rest of the way, I'm going to divide by 2 on both sides. And I get y is equal to 300. What does that mean? What does y represent? Y represents the amount of adults. So I now know 300 adults attended. But I also want to know how many children attended. So the way I'm going to do that is take this y equals 300 and substitute it back into one of my equations. Personally, I'm going to choose this one right here because it's going to be way easier. So I have x plus 300 is equal to 400. Subtract 300 from both sides, and now I'm at x is equal to 100. What are these two things telling us? I have y equals 300, x equals 100. What does that mean? Well, it means 300 adults and 100 children attended the show. And that is answering our question, which was the last sentence of our word problem. All right, we're doing the same exact thing in this next example. It says a baseball game costs $10 for children and $15 for adults. There are 1,000 seats in the arena. If the box office profited $13,250 for a particular night, how many children and how many adults attended the game? We weren't told that they sold out, but we're going to go under that assumption. So let's identify our variables. X equals children. Y equals adults. And now let's write our equations. So it's $10 per a child, so 10 per X, plus $15 per adult, so that's plus 15Y, is equal to their total profit, or $13,250. We also know that there's a total of 1,000 seats in the arena. So some amount of children and some amount of adults attended this game, and there were 1,000 seats filled. So I have X plus Y equals 1,000. Alrighty. Now I have my two equations, and I'm going to solve using elimination again, like I did up here. So I want to eliminate my X just because it's a smaller number. So the way I'm going to do that is by multiplying the bottom equation by -10. I'm multiplying the bottom equation by -10 because I need one of my variables to cancel. And in order for them to cancel, we want them to be additive inverses of each other. So let's rewrite these two equations over to the side. I have 10x plus 15y is equal to 13,250. And then when I multiply this -10 across the parentheses, I get -10x minus 10y is equal to 10,000. -10,000, my apologies. Now I'm ready to add these up vertically. My x's cancel. 15y and -10y is positive 5y. And 13,250 minus 10,000 is 3,250. I now need to divide by 5 on both sides, and I get y is equal to 650. I put that into my calculator to get that. So there's my first variable. It didn't only want to know how many adults attended, though. It wants to know how many children and how many adults. It's asking both of those. So I'm going to need to use that number and substitute it back into the bottom equation. When I do that, I'm going to get x plus 650 is equal to 1,000. Subtract 650 from both sides. And now I have x is equal to 350. So for my final answer, I'm going to say 650 adults and 350 children attended the game. This then answers the question that it was asking. We just have 2 more examples and then we'll be done with this application of systems of equations. Alrighty, in example 3, it says a school district is planning on buying new desks for its classrooms. Each secondary classroom, this just means high school, each high school classroom is to have 4 more desks than an elementary classroom. For 40 elementary classrooms and 50 high school classrooms, a total of 2,450 desks are needed. How many desks are to be in each kind of classroom? So this is a little funky, just kind of the way that it's worded, but first let's identify the variables. A great spot to look if you're not sure about variables is to look at the question. It says how many desks are needed to be in each kind of classroom. So that's what it's telling me. It's going to be X means number of seats in elementary class, while y is equal to the number of seats in a high school class. Okay. Now that I know that, I can go back and start rereading my problem to see if I can write some equations. This says each secondary classroom is to have 4 more desks than an elementary. So that means high school, y, needs to be the amount in an elementary, x, plus 4. It also says that there will be 40 elementary classrooms and 50 high school classrooms with a total of 2,450 desks. So that means 40 per however many seats there are in an elementary room, plus 50 per how many seats there are in high school rooms, is going to equal however many desks we have, which is 2,450. These are my 2 equations, and we want to decide how should I solve this, substitution or elimination. I personally think that substitution will be easier here because this equation is already solved for a variable. So I can take this y equals x plus 4 and replace this y with that in the bottom equation. So let's rewrite the bottom equation now, and it's going to be 40x plus 50 times x plus 4 is equal to 2,450. Okay, now distribute. 40x plus 50x plus 200 is equal to 2,450. I'm going to combine like terms. This is 90x plus 200 equals 2,450. And I'm continuing to solve for x, so I'm going to subtract 200 from both sides. And I have 90x is equal to 2,250. Finally, I want to divide by 90. You're going to need to put that into your calculator. And I get x is equal to 25. So what is this x equals 25? That means there should be 25 seats in each elementary classroom. But I also need to figure out how many seats should be in a high school classroom. Well, I can take this x equals 25 and substitute it back into either one of my equations. But to be honest, I think this one right here looks quite a bit easier. So I'm going to say, I'll do it in a different color, y is equal to 25 plus 4, or y is equal to 29. Alrighty, I have my x value, I have my y value, but what do they represent? Let's write out in a sentence what this is saying. So there are 25 desks in elementary classes and 29 desks in high school classes. And this right here is going to be my solution. One more example, and then we are done with this note section. It says a 7-year-old girl is selling lemonade and cookies. She sold 3 more glasses of lemonade than cookies. Cookies cost 50 cents or $0.5 and $0.5 a piece, and lemonade costs $1.50 per glass. The girl made $14.50 that day. How many cookies and how many glasses of lemonade did she sell? That sentence, that last question, is telling us our variables. How many glasses of lemonade and how many cookies? That's what we're trying to figure out. So let's use that to identify our variables. I'm going to say x equals cookies and y equals lemonade. And now we need to go back and reread so we can find our equations that it gives us. She sold 3 more glasses of lemonade than cookies. So the amount of lemonade she sold, which is Y, is equal to the amount of cookies she sold, X, plus 3 more. It then tells us the price per product and the total amount she made. So I can multiply that price by the product and set it equal to how much she made. So it's going to be 0.5 per cookie, so 0.5x, plus 1.5 per lemonade, which is Y, is equal to her total profit, which is $14.50. Okay, I have my two equations. Because the Y is already isolated in this one, I'm going to use substitution. That means take X plus 3 and substitute it in for the Y right there. So now I'm writing 0.5x plus 1.5 times x plus 3 is equal to $14.50. To get rid of these parentheses, I'm going to distribute. So I have 0.5x plus 1.5x plus 1.5 times 3 is 4.5 is equal to $14.50. Combine your like terms. So that's 2x plus 4.5 equals $14.50. And we're continuing to isolate the x. So now I'm going to subtract 4.5 from both sides. So that gets me 2x is equal to 10. Divide by 2, x is equal to 5. So what does this x equal 5 represent? It means she sold 5 cookies. If I want to figure out also how many glasses of lemonade she sold, which I do, I'm going to take this x equals 5 and substitute it back into one of my equations. And I think the top one would be easier. So I'm going to say y is equal to 5 plus 3, or y is equal to 8. So to write my final answer, I need to combine this x equals 5 and that y equals 8 into a sentence. So what do these answers mean? It means she sold 5 cookies and 7 glasses of lemonade. And there you have it. Basically, identify your variables, write your equations by rereading the problem, and then solve using the strategy that you think will work best. I hope you have a great night, and I'll see you soon in class.